Okay, so we had done portfolio construction and management from a risk aversion perspective, which was minimization of risk. And now we will be moving to portfolio optimization. Uh, you can see the case in front of you on the screen. So I'm going to just put this portfolio here. So we have bonds and we have stocks, correct? And the returns and risks are given to you. So for bonds, it is 6% and 10%. For stocks, it is 13% and 30%. And the coefficient of correlation is minus 0.40. ठीक है ना? So when I create this portfolio, I will have the portfolio return first. I don't have my weight, so I can just start with any weight. So I typically start with 0.25 and 0.75. The sum of the weight should be always equal to 1. Right? So now the portfolio return would be equal to what? For my base case, it will be the sum product of my weights and the returns, which is 11.25%. And the portfolio risk will be equal to the square root of weight of A squared into sigma A squared plus weight of B squared into sigma B squared plus twice weight of A, weight of B, sigma A, sigma B into correlation coefficient, which is R. And we got the portfolio risk as 21.62%. Now, if we have to, this was our base case. So I'm just going to focus on the MVP first. So for the MVP, I will just copy the same base case. I will not make any changes to that. I will copy it here. And now use the solver for risk minimization. And call this as my minimum variance portfolio. If I use the solver, I'll just go to the solver here in the data tab. And what will be my objective? First objective in minimum variance portfolio is to minimize the risk. So I set my objective as risk, set it to minimum by changing my cells, which is the weights of the bonds and the stocks, subject to the constraint that the sum of the weights should be equal to 1. And I press OK and I solve it. So this is what I get as my minimum variance portfolio. That means if I have 83%, 82.26% invested in bonds and 17.74% invested in stocks. I am going to minimize my risk and bring it out to 7.81%. Is it clear? We can also validate the same thing using the weight data table. So I'll put my weight of bonds here, weight of stocks here, and my portfolio risk here. And please remember, never ever link it to any other case except the base case, because that is unaltered. So I'm going to link this to the base case, and weight of stocks will be 1 minus weight of bonds. And this is my portfolio risk. And now I am going to start with 0, 0.1 and go up to 1. And यहाँ पे between 0.8 and 0.9, just to check whether the weight is actually getting the minimum risk, I will put this 0.8226 also here. And यहाँ पे I'll just take this. And I'll solve for the data table. So if I take the data table here, and all my data is arranged in a column, the inputs, I just go and select it to the independent input, which is the weight of bonds in this current case. And I'm going to get all my risks here. Now you only look at this and tell me, where do you find the risk minimum? You will find the risk minimum here, guaranteed. This is where your portfolio risk is minimum. You can check it. It is 7.81%. इससे कम रिस्क आपको डेटा टेबल पे कहीं पे दिख रहा है? नहीं, which means our proportion of the bonds and stocks in the minimum variance portfolio is accurate, and it is genuinely giving us the lowest level of risk. Remember, we can also use the formula which I have taught you. So by the formula, you remember the formula, right? This is the formula that we had done, where R is not equal to -1. So if we use this formula here, the weight of bonds will be equal to what? उसके लिए आपको 3 inputs चाहिए: variance of stock, variance of bonds, and covariance between stock and bonds, which is variance of stock is what? Just take the square of the risk. Variance of bonds के लिए भी again take the square of the risks, and covariance के लिए R into sigma A into sigma B. So ये तीनों आपको मिल गया. So weight of bonds will be variance of stock minus covariance between stocks and bonds in the numerator, divided by variance of stock plus variance of bonds minus twice the covariance between the stock and the bonds, which comes to how much? It comes to 0.8226. Is it the same number that you are getting here? It is. So जो आपको सॉल्वर से मिला वही आपको डेटा टेबल पे मिला, and you validated that the risk was minimum, and you also got the same weights for bonds using the formula. What about the weight of stocks? Weight of stocks will be 1 minus weight of bonds, which will be 1 minus this, or 0.1774. So this is what we did for the minimum variance portfolio. Now we will be constructing the optimal portfolio. So I'm going to, again, please only use the base case because that is unaltered. इसको copy करेंगे हम, and I'm going to put this here, and I'm going to call it as the optimal portfolio case. Okay, na? This is the optimal portfolio case. So for optimal portfolio, you need one more output. What is the output that you need? You need the Sharpe's ratio. Formula for Sharpe's ratio is Rp minus Rf by sigma P. So currently, Sharpe's ratio in the current case, अगर हम base case में देखें तो base case में हमारा Sharpe's ratio क्या है? Link it to the base case. What is it? Rp minus Rf. What is it given in the formula? Rf is 3%, right? So minus 3% divided by sigma P. So currently in the base case, the Sharpe's ratio is 0.5433. So it is clearly not optimal, isn't it? So agar मैं for the optimal case also, Rp minus 3% by sigma P. If I have to do this for now, if I need to maximize this, I just go to my solver first. सबसे पहले, as I told you, always reset your solver. That's the first thing that you should do. Reset your solver and set your objective to be Sharpe's ratio. Set it to maximum by changing my weights, subject to the constraint that the sum of the weights should be equal to 1, and solve. So see, I am getting 0.7414 for stocks and 0.7414 for bonds and 0.2586 for stocks. है कि नहीं? And now, what is my Sharpe's ratio? It has jumped from where to where? It has jumped to 0.58. It was something around 0.38. Remember? So what I will do now is I will also construct a data table with the following things. यहाँ पे मैं risk नहीं करूँगा. What will I do? I will do the Sharpe's ratio. देखो, base case में it was only around 0.38. That means there is a 50% or more jump which is recorded by optimization. So अगर मैं weights को plot करूँ, base case में it was 0.25 for bonds, 0.75 for stock, and Sharpe's ratio was around 0.38, isn't it? Now again, I will use the same combinations here. बट यहाँ पे आई डोंट नीड दिस रो, ये मुझे नहीं चाहिए. Rather, I need a row between 0.7 and 0.8, isn't it? And यहाँ पे I will take the, ये 0.7414 यहाँ से ले लूंगा मैं and इधर पेस्ट कर दूंगा. Why? Because I want to see whether actually at that weight combination sharpness ratio is maximum or not. Again, this is my base case, so let this be. And let's construct now and see what happens. So go to data, what if analysis, data table, and choose the column input as the weight of bonds, which is my only independent input in my base case. और यहाँ ओके करो और आप मेरे को बताओ कि यहाँ पे सबसे ज्यादा शार्पेज रेशियो आपको कहाँ पे दिख रहा है. Where are you seeing the maximum sharpness ratio? इससे ज्यादा नहीं मिलेगा, guaranteed. This is the place where you are having the maximum sharpness ratio. That means if I have 74.14% in bonds and 25.86% in stocks, I will get the maximum sharpness ratio, which is 0.5785. Clear? Now we can also do the same calculation with the formula. फॉर्मूला के लिए मेरे को इनपुट्स चाहिए. So I am going to take the inputs here. Variance of stock will be variance of bonds from here, and covariance is R into sigma A into sigma B. And इसके अलावा for portfolio optimization we need two more inputs. We need the delta return for the bonds and delta return for the stocks. Delta is, remember, the excess return over and above risk-free rate. Delta return for bonds क्या होगा? Bonds का return minus 3%. Delta return for stocks will be stocks का return minus 3%. So now if I use the formula, what should I get? We start with variance of stock, जो यहाँ है, multiply it with delta return of bonds minus covariance of stock and bonds multiplied with delta return of stocks. तो ये आपका न्यूमरेटर हो गया. डिनोमिनेटर में variance of stock into delta return for bonds plus variance of bonds into delta return for stocks minus, now we will not do twice here, we will just take covariance and multiply it with the delta return for bonds and delta return of stocks ka summation. So this becomes your numerator, and let's see what you get as the weight of bonds. Do you get the same number? 0.7414 जो यहाँ था वही सेम नंबर यहाँ पे भी है. And weight of stocks will be what? Correct. उसके लिए तो this, you don't need to do much, it is just 1 minus this, which is 0.2586. Now the most important part of this portfolio management and rebalancing is to create a summary. So let's create a summary here. So if I take the return and the risk combinations and the sharpness ratio in my base case में portfolio return कितना था? 7.24%. Portfolio risk was, oh no, sorry, Base case means the portfolio return was 11.25%. Is that right? And risk was much higher. It was 21.62%, but the Sharpe's ratio was only something around 0.38. Then we did minimum variance portfolio. उसमें return कितना था? It came down considerably, but mind you, the risk also came down considerably, and the Sharpe's ratio came down to 0.5785. And then we came across the optimal portfolio where the return was 7.81. Okay, so minimum variance weight was 7.24 and 7.81, and Sharpe's ratio was 0.5433. And यहाँ पे it will be 7.81, 8.31 and 0.5785. अब मेरे को बताओ, if you are the investor, this is a summary and this is the most important part. If you are the investor, which is the combination that you would go for? अगर आप पहला देखोगे तो रिटर्न बहुत ज्यादा है, 11% है. So don't get infatuated just by returns, because उसका risk भी बहुत ज्यादा है. The volatility in the portfolio is 21%, almost double. फिर अगर आप सिर्फ एक तरफा हो जाओगे और सोचोगे कि यार मेरे को खाली अपना रिस्क कम करना है, वो भी उतना सही नहीं, because the reward per unit of risk is only 0.54. That means for every $1 of risk that you are taking, you are only getting 54 cents of incremental return. लेकिन अगर आप पोर्टफोलियो को ऑप्टिमाइज करते हो, you are getting the highest reward per unit of risk. That means इस केस में for every dollar of risk that you are taking, the max you can get is 58 cents of return, which is the highest. So if you are open to taking risk, now there's no right or wrong. As I mentioned, it's entirely based on the investment profile and preferences of your investor. If he is risk averse, he will probably go for an MVP, but if he is rational and risk seeking, he will settle for the optimal portfolio. Clear? Okay, so that's it. Thank you.